Okay, let's start. So, what we were doing previously was we were breaking apart vectors into its components, right? For example, if you have a quick recap for, let's say, velocity, we know that velocity is a vector it's a vector, right? It has a direction as well as a magnitude. Now, if a vector is at an angle, that means in this case, if you take the compass of, let's say, this is north and this is south, and then this is west and this is east, you can see that this vector is going a little bit to the right and it's going a little bit to the upright. So that means this vector is it's an addition of both going to the right and both going to upwards, right? So you could say that this angled vector is composing of two components. It's going a little bit up and it's going a little bit to the right. So when you combine both of these vectors, these upwards and rightwards vectors, you get this 5 meters per second at 30 degrees. How can you, like, for example, how can you always break apart vectors into their components? How do I know how much is the vector upwards and how much of it is towards the right? You can figure it out by simply using, so for example, 5 meters per second at 30 degrees, right? What you can do is, this clearly consists of a horizontal component as well, right? And it consists of a vertical component as well, which is this one, right? So both of these components, horizontal and vertical components, are combining to make up this 5 meters per second at a certain angle, right? And you could also write it over here or you could write it over here. That's basically the same thing. Now we already derived that the horizontal component is always just, for example, is always just the hypotenuse times cos theta, right? And the vertical component is always hypotenuse times sine theta. Now, in this case, the hypotenuse is basically just equal to 5 cos 30, and the vertical component is just 5 sine 30. And that's how you can find out the component of any two vectors. It could be any direction, by the way. For example, you could find it out for this one. For example, if a vector is like this, it could be, for example, yes, like this. Okay. So let's say if it's pointing downwards, okay, so that means it's pointing somewhere downwards, let's say at an angle of 45 degrees. Okay. Now, how can you break it apart into two components? Again, if you have a look at it, let's draw a compass. It makes it very easier to visualize. So again, this is north, this is east, and this is south. So this is somewhere between east and somewhere between south, right? Or you could say that it's going a little bit to the right and it's going a little bit to the bottom downwards direction. And when you combine them, you get this angled vector at 45 degrees. Now, how do I figure out what two vectors are combining to make this angled vector? I can simply break it into its component. Again, how? If you look at it, I'm going to remove the compass now. So it's going 45 degrees downwards. So that means this is the component which is going towards the right, right? This, you could say, this is the horizontal component. And this would be the vector that is going towards the downwards part, right? So this is the vertical component. And let's call the hypotenuse as, I don't know, h. Okay. So then how do I find out the vertical components? Because it's in front of the angle, I'll always remember that if it's in front of the angle, it's basically h sine theta, or the vertical is always h sine theta, and the horizontal is always h cos theta. In this case, it's 45, and that is also 45. So you can break apart any angle vector into its components. Okay. Any questions so far? We've recapped what we previously did. Yes, Ares. Anya, Kaima. No? All good so far?
Yeah.
Can't hear you guys.
Yeah.
Yes? Okay. Yes, Hania?
Yeah, I got it now.
Okay. Kaima, got it? Now we're going to do questions.
Yes.
Okay. So let's see. Now, if I want to solve a question, it makes my life much easier when I know the breaking apart of vectors. For example, I've got this question which says that you've got a boat, okay, and there's someone that's pulling at 8 newtons over here, and there's someone that's pulling 10 newtons in this direction, and there's another person that's pulling with a 3 newton force backwards, right? So the question is, find resultant force, FR. Okay, now how do I find resultant force? RS, would I simply just do 8 plus 10 minus 3? What do you think?
No.
No, I cannot do that. Why? Because these are not all at the same angles. You first have to make sure they're all at the same angle. So what do I do over here? Any idea, guys? How do I like do this question? How do I find out the resultant force?
Would you use the parallelogram method?
Okay, but I don't think so. That would be very accurate. And how will you then, how will you do it for the, what is it? How will you do it for the minus 3 newtons? For example, let's say you use the parallelogram method for this, okay? You drew an 8 Newton over here, okay? Then you drew another 10 Newton over here, and then you join the diagonals, right? And you got this to be your resultant force. But do you see that, let's say you got this at, I don't know, let's say you got 9 Newton as the resultant force, but it's still pointing like slightly towards the down. It's slightly pointing south, right? But
Yeah.
how will you like subtract this 9 Newton from this 3 Newton then? Right? That's another problem then, because these
Yeah.
3 newtons and 9 newtons are not at the same angle. So in these cases, in the parallelogram method is always useful when you just have two vectors, and you've been asked to do the parallelogram method, but it's not accurate at all. Now what we're going to do is, now we're going to use the vector resolution method. The vector resolution method. So first of all, wouldn't it be easier to break your 8 newton and 10 newton into vectors of x and y? I think I could pretty easily break apart my 8 Newton and 10 Newton into parts. So let's check. For example, this, in fact, let's make it bigger. Okay. Okay. So this 8 Newton has a horizontal component as well as a vertical component. This is the horizontal component of the 8 Newton force. Now, how do I know what that is? How do I know what is the horizontal component? I know that the horizontal component of this is, it's always the hypotenuse multiplied by cos theta, the horizontal part, right? With the angle, it's always cos, and in front of the angle, it's always sine. So this is just going to be 8 cos 45. Okay, so that means this is basically the rightward part, or this is the horizontal part of my 8 Newton force. But it's not just the horizontal part. You have to figure out what the vertical part of that force is as well. Now, the vertical part is
Wait,
basically
so
just going to be this vector. Yes,
so how is it 8 cos 45?
8 cos
Like
45. Do you
how
remember?
how is it cos 45?
Oh, sorry, it's 35. It's
Oh,
35.
okay, okay.
35. Okay. Now, this is the horizontal part, right? And the vertical part would be this arrow pointing upwards, and we derived it earlier, that the vertical part is always sine. So that means this part is going to be 8 sine 45. Okay, so what I've done is I've basically drawn 8 sine 45 and 8 cos 30. This is 35 again. 35. So both of these horizontal and vertical vectors are combining to make this 8 Newton force. So now what I can do is I can get rid of this force. Why? Because because this 8 Newton force is a result of these forces acting. So that means I can say that this force does not exist anymore because I've broken it into its part. It's kind of like, I've gone to its roots and figured out what that force was. Okay. Now the 10 Newton force. The 10 Newton force also has what? It also has a vertical component and a horizontal component. So the horizontal component is going to be this, right? This is going to be the horizontal component of the 10 Newton force in this direction. This is going to be what? Again, because it's with the angle, that means this is going to be 10 cos 45, cos 40, right? And what is going to be the vertical part? Yes, Anya.
Then
It's gonna be sine 10 sine 40.
It's going to be 10 sine 40. Okay, that means I can now get rid of this force, and I've replaced it with these two forces. Do you see that now it's much easier? Because now for the boat, I have gotten rid of the angled vectors and I've boiled them down to their vertical and horizontal components. So that means now I have like, I have got an upward force, right? Which is 8 sine 35. Okay. I've got a downward force, which came from the 10 Newton. This is 10 sine 40. And I've got two forces that point to the right. One of them is 8 cos 35 and the other one was 10 cos 40. Okay. And now I also have another force. I have got the original 3 Newton force pointing horizontally as well. So that means, do you see that now I've boiled them down to the horizontal components and the vertical components? It's much easier to subtract them, right? Right? So if I were to just talk about the vertical part, right? What is the vertical resultant? Yes. Can you find out what the vertical resultant force is? So that means I'm just talking about these two forces. Because if I'm talking about vertical, I can only add or subtract directly the vertical forces. It would just be 10 sine 40 minus 8 sine 35, right? Because that's, pointing upwards and that's pointing downwards. So I can easily subtract them just like, 5 and 3, 5 minus 3 equal to 2. In the
See,
same way, I
but
can subtract these two as well. Yes.
sir, won't 10 be negative though? Because that one's going downwards, right?
That's fine. You can choose whatever you like. That's fine. You just have
Okay,
to
so
make
there's no
sure.
problem
There's
with
no
you
problem.
taking
But
it.
for example, let's say you take your answer as this. Okay, 10 sine 40 minus 8 sine 45. Let's say that the answer comes as positive. That means that this force was greater than this force, right? So let's say it comes out at positive 2. Now, because you subtracted 10 sine 40 from 8 sine 45, and this is greater, so that must mean that the net force is in this direction, right?
Yeah.
Right? So the sign doesn't matter, huh? You can choose it to be, for example, this as positive and this is negative. That would be right as well. You can do that either as well. So you could do 8 sine 35 minus 10 sine 40. The answer will likely be negative. So let's say it comes out to be negative, I don't know, 3, right? Now, because you've chosen downwards to be negative, then you will have to obviously choose that minus 3 is going to be pointing downwards. So that means for vertical parts, your resultant force will be downward. So you can choose whatever you like, but you've got to stick with it.
Wait, so sir, there's both vertical and horizontal resultant forces then.
Exactly. We're going to now find out both the vertical resultant force and the horizontal resultant force, and then we're going to combine them together to see what the resultant force actually is. Because in this example, you've got multiple forces acting. You've got like this angled force, you've got this angled force, and you've got this horizontal force. So these are the horizontal forces. First, you've got to like find out the horizontal resultant, and you've got to find out the vertical resultant, and then try to bring it down to only two forces. So the vertical resultant force, let's take the upward as positive. Okay, let's take upwards as positive. So that's 8 sine 35 minus 10 sine 40. Okay, I'm just doing resultant force, like 5 minus 3. I'm just doing that for the vertical part for now. So 8 sine 35 minus 10 sine 40. Make sure your calculator is in radians. Oh, sorry, degrees. So minus 1.84 newtons is the vertical resultant force. So that means instead of writing these two forces, the resultant came out to be minus 1.84. That means if you were to find out the net force for both of these, right, like which one is pulling more strongly, it's minus 1.84, which is pointing downwards, minus 1.84 newtons downwards.
Excuse me, sir. Can you please explain
Yes.
what you explained before this? Because I got disconnected from the meeting.
Okay. Which point did you get disconnected?
I think like before this part.
Before this over here or before
No,
that?
yeah, no, after that.
Okay. So what we basically, did you get it up to this point that we broke apart the 8 Newton, 10 Newton into pieces of vertical and horizontals?
Yes.
Yes, so we broke the 8 Newton into its horizontal component and vertical component, and we broke the 10 Newton into its horizontal and vertical components. Now what I'm going to do is, I have both horizontal vectors and I have both vertical vectors. I am now going to find out the horizontal uh, resultants separately, and I'm going to find out the vertical component separately. So what I'm doing right now is, I am just talking what is the horizontal resultant force. So I basically just subtracted this value with this value. Just like, for example, if there's a box and there's someone pulling up with a force of 3 and there's someone pulling down with a force of 5, right? So how do I find out the resultant force? That's 3 minus 5, right? So I'm doing it in parts where I'm just finding out for now the vertical force, vertical net force. Then I'm going to find out the horizontal net force. Okay. Yes, Kaima, makes sense? It'll make
Yes.
more sense in just a bit. Okay. So I found out the vertical resultant force. That means the net force for the vertical forces is minus 1.84 Newton. Okay. So that means the effective force from both of these up and down ones is that the downward force is stronger. Okay. Now I consider, so this was the vertical resultant force. Okay. Now I consider only the horizontal vectors, the horizontal resultant forces. So again, let's pick off the box, and now we only talk about the okay. Now I'm only going to consider the horizontal resultant forces. So let's say this is plus 8 cos 35, this is 10 cos 40, and this was minus 3, right? So let's add them up and see what is the net force. Just like two people pulling forward and one people pulling back, one person pulling backward. What is the resultant force? You just add them and subtract them. So 8 cos 45 plus 10 cos 40, right? And then when you add these two together, you get minus 3 as well because this person is pulling in the opposite direction. Let's check. Yes, Anya, making sense? Cos 40.
Yeah.
10 cos 40 minus 3. Minus 3. The resultant force is plus 10.3 Newton. That means if you take the resultant force of just this box, the horizontal part, it's actually plus 10.3 Newton resultant force. This is only for the horizontal part. Okay. So now let's compare what we've just found. We found out what the horizontal net force is. We found out what the vertical net force is. And now let's compile what we've learned so far. Okay. We took the box. And do we know what the horizontal net force was? Yes, we do. It was pointing towards the right, 10.3 Newton. This was horizontal. Okay. And we had another force, which was pointing vertically as well. That was minus 1.84 Newton, right? So it was pointing downwards. So do you see that this is the net vertical force? Okay. And this is the net horizontal force. Now the original question was, different people are pulling like this. Find the resultant force and its direction. Now, how do you find out the resultant force? I think we've learned that pretty well much earlier, that if you have this force pointing downwards, you have this force pointing downwards, we can find out the resultant force, right? How can you find out the resultant force? Yes, we made the problem much simpler now.
Like, um, from like the head to the tail of one vector.
Exactly. You just take Pythagoras, you join them head to tail now. Now, if you join them head to tail, that's it. So that means you join them head to tail and then you join them tails to heads. So this is going to be a resultant force. This was minus 1.84. This was 10.3, right? And if you want to find out the resultant force, what you do is you use Pythagoras. That means 1.84 square plus 10.3 square under root, and you get your answer resultant force. That comes out to 1.84 plus 10.3 squared 10.3. 5 newtons. So that is the resultant force. So that means if you were to know, now go back to your original question, the question is telling me that if you use all of these forces, okay, you combine all of these 8 Newton, 10 Newton, 3 Newton. If I use this resultant force, this came out to be my actual, my direction of the force somewhere over here. So that means the resultant force would be somewhere over here with the force of 10.5 Newton. And that is by combining all of these forces. And you can even find out this angle, by the way. You can even find out the angle, for example, uh, you could find out this angle. You could also find out whatever angle you want, but you could also use this point, for example. How much is the angle pointing downwards from the horizontal? That's up to you. But in this case, let's just, be satisfied with just finding out the resultant force. Make sense? So that's how you find out the resultant force when you know the problem is much more weirder and difficult and it has a lot of angles associated with it. You break it apart. First, what you do is you break apart all of the forces into its horizontal and vertical components. Then you find out the vertical resultant and the horizontal resultant separately. Then at the end, you only have the horizontal component and the vertical component, right? You just have like two forces, and then you will just use Pythagoras to find out the resultant. That's it. That's the way to find out, the resultant force. For examples where you can't really use, the parallelogram or the scale diagram method much accurately. Yes, questions. Yes, Kaima. Did you get it?
Yes.
Yes, Hania, got it?
Yes.
Yes, are you sure? It is a pretty complex topic. That means I've done a really good job explaining it.
Yeah, like till now I got it. So
You got
hopefully
it.
I can.
Okay, that's good. By the way, this isn't a single question. This is like don't worry, this is not a single question that you will get, for like 2 marks. This is a big question, and the total marks could be like 7 for this question, or, like at least 5, where you first, break it apart into its components, 2 marks. Then you find out the vertical resultant force, 1 mark. Then you find out the horizontal resultant force, 1 mark. Then you find out, what is the actual resultant force by using Pythagoras. This would be worth like 2 marks. So don't worry, this is not a single question. It's a it's a big question that is broken into parts. Okay, so you'll have multiple, you would have lots of time to solve that question, but this is just, trying to solve the problem in a single go. Okay, makes sense. Perfect. Now we're going to do another very similar question, and this one's on you. Okay, very similar question again. There's a treasure box. Okay, and 3 people find it, and most of them obviously want to keep the treasure for themselves. Now, this person is trying to go over here. He's trying to pull with 50 newtons on this side. There's another person that's trying to pull in this direction. And there's another person that's trying to pull towards the left. The question is, to which side will the treasure go? Who is going to win? Who's going to win the treasure tug of war? It might not be really apparent by just the magnitudes of the forces. Why? Because there's lots of forces over here. You can't really do 40 is greater than 30. You can't really do 50 is greater than 30. Why? Because they're at different angles. So you can only add vectors if they have the same angles. So yes, Aris, will you be able to do this? To which side will the treasure go? And you will have to use vector resolution.
Okay.
Okay. I will give you guys 6 minutes to solve it. It should not take you more than that. Okay. Your time starts now. 3 minutes remaining. Yes, Hani, are you able to do it?
Yeah, I'm trying till now.
Okay. Yes, Kaima. Where have you gotten so far? Yes, Ariz, what's your progress?
Um, I'm finding the horizontal result at first.
Okay, okay. I'm going to start solving it in front of me as well. So then we can move on to the next question. Okay, but again, solve it by yourself and only look at the solution once you've done your part or if you're stuck. Okay, so
So
yes.
I got my answer.
Okay, let me
I
check.
got it as 5.99.
Okay, I don't know the answer, but let's check. Keep watching the solution. Yes, Aris, what did you get as your answer?
5.99. Same thing.
Yep, that's right. 5.99 is the correct answer. And by the way, so okay, so we figured out what the resultant force is. This is the resultant force which is pointing somewhere over here, 5.99 Newton. So if I want to calculate what the angle of that force is, let's say I calculated, I calculate this angle. So how do I calculate this angle? Hmm. So if I want to calculate this angle, how do I, so let's take this triangle, right? What was the horizontal part of this? This was minus 5 Newton. And what was the vertical force? That was 3.3 Newton. So that means if I want to find out this angle, I can simply bring this force over here. It's the same thing. And if I want to find out what this angle is, I can simply use tan theta or whatever you want. Tan theta is equals to perpendicular over base. So perpendicular over base. So theta was equals to, what was the perpendicular value? That was 5. What was the base? That was 3.3. And you do tan inverse. $56.6 at 56.6 degrees southeast. That's how I specified it. Okay. And that's your question. So that's how you figured out the resultant force. I'm sure the resultant part was easy. You figured it out. The angle part, we've already done that multiple times. Basically trying to find out where the resultant force is. Like, is it going, if you were to draw the compass over here, we know that this is north, this is south, and this is east. The resultant force is somewhere between south and east. Is it more towards east? Is it more towards south? You've got to figure that out by using the angle. They'll always tell you from which point to take the angle. I've just assumed I've taken the angle from the horizontal part, but they will obviously tell you, calculate this exact angle and you'll be able to pretty easily figure it out. Okay. Yes, Hania, got it or no? I've even written
I
down the instructions over here.
Yeah, I got it to 5.99
Hmm.
and I forgot to calculate the angle. So
That's fine. That's fine. But you do know how to calculate the angle, right? We've done that previously as well.
yeah.
Okay. Yes, Kaima, got it? It's
Yes.
very okay, perfect. So now let's try solving this question. So let's see. Wait. So let's calculate this question, which says a box of mass 50 kilograms is held stationary in air. Okay, so that means this is a box that is suspended in air, and it says find the tension T provided by the cables to hold it up at its center of mass. And it's, being held perfectly equally symmetrically, okay, with an angle of 60 degrees between both of these wires. And this box is obviously hanging downwards. Now, what you hear from stationary is a very, very important word over here. That means that it is not moving. If it is not moving, that tells you something very important, that your acceleration is zero, right? If acceleration is zero, that must mean your resultant forces are zero. And what does the resultant force zero equal mean? That means that your forces are balanced. So stationary tells you a very, very, very important point, that the forces are balanced in this example. Can you try solving it? Yes, Ares, what do you think? How should we solve this question? Any idea?
Wait, so both
Hmm. The tension provided by the wires are equal. So T left is equal to
Okay.
T right. What do you think we
Mm.
should do?
Wait, then that means both the angles will also be equal, right?
Yes, yes, you're right. It will be.
And then
The
the
60
mass that
degree,
is
keep
down.
in mind, the 60 degrees for the entire arc for both of them.
Wait, so would the downward force be 50?
It will not be 50.
50 into
Ah, yes,
9.8.
exactly. Because mass is not a force. There is an additional force that's acting downwards, right? Which is the weight. And weight is basically equal to mass times g, 50 into 9.81. So this is the extra force that was hidden. Now, what you've got to do is you've just got to figure out what T is. Okay. I'll give you 4 minutes for this example. It won't take you even that long, and try solving it out. I'll be right back. Do solve it and figure out what the answer could be. I'll be back in 4 to 5 minutes. Yes, guys, I've been gone too long. Hope you were missing me. Yes, Ariz. Are you done?
Yeah, I am. However, I'm not sure
Yes.
if I got the right answer.
What did you get the answer as?
I got the answer as 1338.80 Newton.
1338.8. Okay. Hania, what about you? Kaima, what did you get?
I got 490.5.
Okay, okay. Kaima, what did you get? Did you get an answer?
No,
T.
I couldn't solve it.
Okay, let's check. So you both have different answers. I'm not sure which one is the correct one. So first of all, when a resultant force is zero and you say or you hear the word stationary, right? Or you say acceleration is zero, or you hear the word equilibrium, the primary thing that should, come to your mind is forces are balanced. Now, if forces are balanced, that means forces are balanced in every direction. In every direction, because if they were not balanced in a single direction, then that weight or that object would tend to go in that net force direction. So forces are balanced in every direction in this case. Okay. So if you write down the forces, okay, you've got one force which is downwards. In fact, let's just get rid of the box. Let's just draw a circle instead of the box. You've got one force that is downwards, which is, what was the weight? Weight force was what? 490.5, right? 490.5. So far, so good. 490.5 Newton is the weight. Okay. Now you have two upward forces. There is one T which is pointing over here, and there is one T which is pointing in this direction. We know that they're both equal. And because it is being suspended at the center of its mass, right? And you've got the same force from both sides. If the angle between them is 60, then you can divide it. You can divide this each side into 30 and 30. You can say that this side is 30 degrees, and you can say that this side is 30 degrees as well. Okay. Now the problem is you can't directly add these. What if you broke this into its components? What if you broke the tension into its components? Can we do that? We can. I can say that this part, so I have this angle, by the way. I have this angle, right? Now I can break it into its components. I can say that this is, let's say, this is the vertical part, okay? And this is the horizontal part. Let's say, let's use a different color. So, okay. So you've got this force, which is the upward force of tension, upward part of tension. And this is the rightward part of this tension. Okay. Now the problem is you have this angle, right? Now, if you have this angle, then how do you find out? Is this force T cos 30? Is this T cos 30 or is this T sine 30? What do you think?
The horizontal would be T cos 30 and then the vertical would be T sine 30.
Okay. Now, here's where it gets interesting. In this question, this is not going to be T cos 30. Why? Because the angle that you've been given is actually this one. If you notice that the angle that was given in all my previous example was, you were given this angle theta, right? But in this case, you're actually given this angle, right? So if you've been given this angle, then it's right. Then you're absolutely right that if this is T, this would be T cos 30, cos theta, right? And this would be T sine 30 or T sine theta, right? But in this example, the angle is actually this one. The angle is actually this one. So now you can't exactly use T cos theta and T sine theta in the same way. What I want you to remember is the key that's always true, that in front of the angle, okay, in front of angle, in front of theta, it's always sine, and with theta, it's always cos. So that means adjacent. So that means you could say that the adjacent is always what was it? The adjacent is always cos and the opposite is always sine. Okay, but now we've actually been given the other angle. So let's see. You've actually been given this angle 30. So what do you do? First of all, let's just break it into its components. So this is the let's say the vertical component. Okay, this is the vertical component, and let's say that this is the horizontal component. Okay, I can draw it either ways. I can draw it over here as well. I can draw it over here as well. Up to me. Now, do you see that the angle is actually over here? So that means in front of the angle, that is actually going to be t sine 30. So in this case, do you see that the horizontal is actually, the horizontal is actually my sine value. So it's not always that the horizontal component is always sine or it's always cos. You have to look what angle has been given. In this case, it's actually the angle over here. So that means it's going to be in front of the angle. So this is t sine 30. So this force is t sine 30. What about the vertical force? The vertical force is going to be t cos 30. Why? Because the angle that has been given is this one. Okay. Now,
Sir?
what about the other? Yes,
So what if you like do it the other way? Like, what
you could get the
since
same answer. You could get
I
the
mean
same answers.
if this is 30, then the other angle
Uh,
would be
that
60,
would be
right?
60. Yes, yes. So that would
Yeah,
mean
so then can we do it like that? Because I did it
yes,
like that.
that's fine as well. You can do it that way as well. So for example, if you've been given this, Anya, what method did you use? Did you use the angle 30 or did you use 60?
I use 60.
60, that's fine. You can do it for 30 as well, but you've got to be careful what you're choosing. So in this case, I could, if I take this angle, I know that this is 60, right? And this is also 60. This is 60 and this is also 60. So if we were to find out the horizontal component of t, this is going to be t cos 60, right? And this is going to be t sine 60. But so is this. So is the other side as well. This is going to be t cos 60 and this is going to be t sine 60. Okay, now let's, write down the forces we've got so far. First of all, we've got two forces of t sine 60 that's pointing upwards. I'm just, redrawing them on a neater diagram. Okay, so I've got two forces that are of the exact same magnitude that are pointing upwards. Okay, and what are the horizontal forces that's been acting? Yes, t cos
The
60.
horizontal would be 0, right?
Exactly, t cos 60 and t cos 60. Because t cos 60 is equals to t cos 60, they both cancel out, right? So that means horizontal forces actually cancel out. Forces is equals to 0. Why? Because, they cancel out. If you subtract t cos 60, if you subtract 2 minus 2, it's going to be 0. So that means these don't exist. Now, I've only got one other force, which is the weight, which was 490.5 Newton. I simply just have to take the resultant of them. So do I know that the forces are balanced, right? The forces are balanced in every direction. So that must mean that t sine 60 plus t sine 60 should equal to 490.5 Newton. Why? Because the vertical forces are also balanced. Vertical forces are balanced. So that's how you can equate them. Now let's check. Because these two are the same, I can simply say that this is 2 multiplied by t sine 60 equal to 490.5. So t sine 60 equal to 490.5. I divided it by 2. And if I want to find out t, then I'm going to divide sine 60 on the other side as well. So t is equals to 490.5 divided by 2 into sine 60. Let's check what the answer is. So 490.5 divided by 2 into sine 60. Okay, my answer is 283.2 Newton. This is the tension. Now, neither of you got the answer right. So, where did you go wrong, guys? I don't know where you did.
I
Yes,
forgot to
Aris.
cancel out the horizontal components. And then
Horizontal
what
components?
what I
No. The
also did
horizontal
was
components don't matter because they cancel out.
no, like I instead just put T cos 60.
Ah, no, you've got two components of the tension, right? You have this
And then
vertical component and this vertical component as well.
like I also minused 2T sine 60 from 490.5.
Minus 2 sine 60. One
Yeah,
second.
so basically I put 0 is equal to 490.5 minus T sine
Okay,
60
okay. So basically, the
plus
vertical forces are
T cos
balanced. That
60.
must mean if the vertical forces are balanced, that means the up forces should equal was my up force and this was my down force. They can only be balanced if the up equal to down. So when you equate them together, you can simply find out T. Yes, Hania. And Kaima, did you get it? Did you find out, were you able to understand what T is and how we found it out?
Yes.
Yes, sure. Can you do the question by yourself now if I give it to you? A similar question. Yes, Kaima.
Yes.
Yes. Are you sure? Okay, great. Yes, Hania. Did you figure out where you went wrong?
Yeah, I got it now.
Where did you mess up?
I only took one sine
Ah,
60 instead of two.
one sine 60. Okay, okay. Make sure you take both because you've got two ropes, right? Both of them is going to have a vertical component. Okay, great. Perfect. That'll be all for today. I'm giving you a similar question as homework. Okay, this is a past paper question. Homework question. Okay. It will take some time. I've even drawn it out for you. There's one separate thing over here. There's one slightly different idea over here. You've again got two ropes, okay? One is pointing towards this angle, 40 degrees, and you've got another rope that's pointing at T2. You've also been given the angle at which they've been suspending, and you've been also been given the weight. You have to find out T1 and T2. That is the question. And the very, very important note is that T1 is not equal to T2 in this example. This is a past paper question. This is worth 4 marks. It's a past paper question that came earlier. Okay, I'll send it in the group as well. Then, okay, any questions? Yes, guys. I'm sure you're pretty tired by now. Lots of forces and vectors. But yes, I hope that you are now better versed with vectors. Yes, Ariz.
Yeah.
Yes, are you better able to solve vectors now?
Yeah, I guess so.
Yes.